what we did is we determined what was what kind of a conic was what kind of a conic, and what made them all different, and all that fun stuff. Okay? Refresh my memory. What's the visual clues that I need to see if it's a parabola or not?
One variable squared.
One variable, and only one variable is squared. What's the visual clues that I need to see if it is a hyperbola?
You subtract the square term.
So there's two squared terms, and we subtract them. What's the visual clues that I need to determine if it's a circle or an ellipse?
For the circle, the coefficients are the same. And the ellipse, the coefficients are different.
You gotta be a little more specific. How many squared terms are there? Two. What the middle, or what's in between the two squared terms? An addition sign. Okay? And so then if it's an ellipse,
Coefficients are different.
on the squared terms, right? Okay, so the coefficients of the squared terms are different if it's an ellipse, bless you. They're the same if it's a circle. Okay? So with that being said from Friday, what kind of a conic is this? Why is it a parabola? There's only one squared term in it. Okay? Which variable is squared? Y. So this is a parabola. Its standard form would be y minus k, quantity squared, equals plus or minus 4p times x minus h. Correct? When I go to graph this one, which direction is this parabola going to open? Up, down, or left and right? We don't know yet because we don't have it in standard form yet, but we can get the general feel. Left or right? Okay, this is going to be a left or right one because y is squared. Okay, all right, I like it. So, what we need to do then is we need to take this equation and we need to make it look like the standard form. So what I'm going to do is refresh our memories here on completing the square. We said on Friday that when we're completing the square, the first thing we do is we space out our equation. Then we factor the variable part so that the coefficient on the squared term is 1. Then we set up what b is. It's the non-squared variable. Okay. Then we find b squared and, b over 2 and b over 2 squared, because b over 2 squared fills the space. We balance our equation, and then we factor the left side. We did all of that on Friday. So, fasting forwarding to, sure we are, we're fasting forwarding to there. Okay, so we now need to complete the square. So what I'm going to do is I am going to set up this equation. I'm going to space it out, if you will, by moving the 20x to the other side. Because in my standard form, the only thing that I have on the left side is that squared term, and that squared term's variable. Okay? So now I ask myself, what is b? What is b?
Would b be the 20?
No, the b would not be the 20.
So b is the coefficient of the non-squared variable.
Okay, so which variable am I trying to square, or which variable am I running completing the square on? X or y?
It's the non-squared variable.
Which variable am I running the completing the square on? X or y? Which variable? X or Y? There's only one squared, so there's only one answer. Y. You're running this on Y because that has the squared term. When you're running completing the square, right, you need a squared term. Okay? So what's the B value then in terms of this problem? The B value.
B -10.
Negative 10. It's right here. What's that number divided by 2? What's that number squared? Okay. And we said on Friday that that squared part at the end fills the space. But now what have I done? I've unbalanced my equation, so I'm also going to have to add 25 to the right side of my equation. So now I get on the left side, this factors into be y minus 5 quantity squared. And I get that minus 5 from right there. That's why we went through those steps, because it makes it easier on the tail end. The right side of my equation is 20x plus 40. Do I have it in standard form yet? Why not IDB? Okay, so what should I do on the right side? We could factor out a 20. So then this becomes y minus 5 quantity squared equals 20 times x plus 2. Now, is it in standard form? Yes. So now we can graph it. Okay? So let's graph that now. Based off of your notes, and hopefully you've started making a note sheet for Wednesday's test already, what is the first thing that I need to answer? Okay, so which direction does this parabola open? Somebody other than Hannah. Which direction, Emily? Right. Do you agree, Luke? Why?
Because it's the y term is the squared.
Okay, so the y term squared makes it go left, right? So that makes it just go right. Okay. Luke, can you do me a favor? Pick somebody to answer the next question. Okay. Declan, what's next?
Well, you could figure out the center. So it'd be
We don't have a center in a parabola.
R, the
Vertex, yep. Okay. So where is said vertex?
-2, 5.
Do we all agree with -2, 5? Okay. Declan, pick somebody. Oh, I went positive 2, 5, didn't I? Could I? Just buying time for Olivia.
Now you find
Okay, how am I going to do that?
Can I call a friend?
Hmm?
Can I call a friend?
Sure.
Can I call Emily?
Talk to her. Don't talk to me.
Can you help with that? You divide the 20 by 4. Okay, so 5.
So what? Okay, so 4p is really what you should have done, or what Emily was trying to tell you to do, was 4p was equal to 20. That number that's out in front of the squared term, or excuse me, out in front of the non-squared term. Okay, so then that gives you p equals 5. Right? Okay, so now what am I going to do with that? You've already used your phone a friend.
Isn't it? Don't you use the vertex? Do you use the vertex with the okay? Yeah.
Mhm.
So -2, 5 plus or minus.
How many foci are there?
2.
In a parabola? You might want to look at your parabola notes. Where is the foci?
It's like the width of the problem.
Where is the foci? Is it inside the parabola? Is it outside the parabola? Is it on the parabola? Is it? It's where? On the parabola? Give me another chance. Inside the parabola. Okay? So if my parabola opens to the right, where's my foci? Or where's my focus?
Right.
So how far to the right would I go? 5. So I'd count 1, 2, 3, 4, 5. So my focus is right there. So where is it?
Right there. 3, 5.
3, 5. Pick somebody. Okay, because the width is through my focus, right? Okay, how wide is my parabola? It's 20 wide. Okay, I want to go. Okay, so if my parabola is 20 wide through my focus, how am I going to find the 2 points that are on it? Up 10 and down 10 through my focus. Okay, I'm going to go the down one first because it's easier. 2, 4, 6, 8, and 10. So my parabola goes through that black point. Okay? And then I'm going to go up 10. This one's going to 2 and 4 and 6 and 8 and 10. Kind of somewhere up in there. It's way off the graph though. Okay? All right? I like it. Okay? Pick somebody. She's already got, Hannah, you just get to pick somebody.
Dylan?
Dylan, you get to pick somebody. you two have already answered enough questions. Likewise, if you pick Emily, she's going to get skipped too, so don't pick Emily.
Daniel?
So I guess you can find the directory.
We could find the directrix, yes. Oops, that one I wanted to be green. How am I going to find the directrix?
You go to the vertex, and the directrix is outside the parabola, so you would go the opposite way.
So since I went to the right to find my focus, I'm going to go left to find my directrix. Same distance though, right?
Yeah.
Yeah, okay. 1, 2, 3, 4, 5. So right here is my directrix. Okay? Now, what kind of a mathematical figure is that? The green part. It's starts with an L. Ends with ein. It's a line. What's the equation of my line? Because I can't just say it's 5 away. Can't say -7.
X equals 7.
X equals 7 is way over here.
Oh, -7.
X equals -7.
Yeah.
So you do X when it's a vertical line, and
Y if it's a horizontal. Yep. Yep. Pick somebody. We're not quite. Yes, ma'am.
So what is the directrix used for? Like, why do we put it on the directrix?
Because the definition of a parabola is the set of all points that are equidistant from a point we call the focus and a line we call the directrix. Yeah? Pick somebody. Austin.
There's two things I can think of.
Okay.
One, you could draw it in.
We could draw it in. Yes, I like that. Okay. But I'm not going to not let you, oh, tap the brakes. That's still green. You're going to have to double answer it then, too, because that one was kind of easy. You know what I mean?
Yeah.
Okay, so we can draw it in. And what was your other one?
Axis of symmetry.
Fantastic. How would I find the axis of symmetry?
Just horizontal line that cuts in half.
Okay. So, like, it goes through the vertex, right?
Yeah.
And then that also puts it through the focus, right? Okay, fantastic. Do you have an equation for that line?
Y equals 5.
Love it. Good job. Yes, ma'am.
So when your vertex is in the origin, axis will be
It'll either be x equals 0 or y equals 0, depending on which way it opens. Anything else for a parabola? Oops. That one. I'll get you started. Then I'm going to have you graph this one. First off, you should determine what kind of a conic it is. What kind of a conic is this one? Why is it a hyperbola?
two squared terms.
Okay, I have two squared terms,
And you're subtracting.
and I'm subtracting them. Okay, so this is a hyperbola. Based on the fact that it's a hyperbola, is it going to be, looking at it, is it going to be an x squared minus a y squared, or a y squared minus an x squared parabola, or excuse me, hyperbola?
Wasn't the x squared minus y squared?
Because the x squared is already positive? Yep, exactly. So the form that I need to go in is going to be x minus h, quantity squared, all over a squared, minus y minus k, quantity squared, over b squared, equals 1. That's the form that I need to get it in. Okay? So, we need to complete the square how many times? 2, because there's 2 squared terms. Okay? So I'm going to space this one out like this. 16x squared minus 96x minus 9y squared plus 36y equals 36. I've got 2 spaces, 2 gaps to fill in. Now, if I were to go back and I were to say, so we've spaced out our equation. Next, we need to factor our equation so that the x squared and the y squared terms have coefficients of 1 on them. So here, I'm going to factor out a 16. That leaves me with negative 6x. Agree? What am I going to factor out on the y squared? Negative 9. If I factor out a negative 9 here, that leaves me with positive y squared minus 4y. That sign changes in a hyperbola because you're factoring out a negative. Okay? So now I say to myself, self, what's the b on this side? It's negative 6. Is that what you were going to say, Austin?
Yeah.
Fantastic. Okay? What's b over 2 then? Negative 3. And that squared. So this gap gets filled with plus 9, right? But now I've unbalanced my equation. So what do I have to add to the right side of my equation? Daniel says 9. Is he correct? He's not. Declan, why?
Because you have to do the times 16.
Because this 9 right there is being controlled by that 16. So does anybody know what 9 times 16 is? 144. So really over here, I've got to add 144. Okay? Now, I go to here. What's my b for my y's? Negative 4. That divided by 2? Negative 2. That squared. 4. So I'm going to add 4 there. But really, I am subtracting 36 or adding a negative 36. So on the other side, I've got to subtract 36 or add negative 36. Okay? So now the left side of my equation becomes 16 times the quantity x minus 3 squared minus 9 times the quantity y minus 2 squared equals 36 minus 36 plus 144 is 144. Do I have it in my standard form yet? More importantly, I don't have it equal to 1. That's going to be my decider. So I'm going to divide by 144 there to get my equal to 1, which means I've got to divide there by 144 and there by 144. So that gives me the quantity x minus 3 squared divided by 9 minus quantity y minus 2 squared divided by 16 equals 1. Now it's in standard form. Now I'm hoping that we can get this graphed in the next 4 minutes. First off, we determined which way does it open. It's going to be a left and a right one because the x squared, or the x is squared and it's positive. Okay? Where is my center? 3, 2. What is my a value? What is my b value? Okay. So let me move this up just a little bit. Okay, so I have a center at 3, 2. I've got an a value of 3, 1, 2, and 3. I've got a b value. Okay, that's good. And then 2 and 4, so here. 2 and 4, so here. There's my box. Okay. Since it opens left and right, that and that are the 2 vertices. So my vertices are at 6, 2 and 0, 2. Asymptotes. Okay. Ooh, this one put up for sure a little bit more. Yeah. Okay. That gives me there it is. There it is. Whoa. There it is. There it is. So that gives me the slope of my asymptotes is plus or minus 4/3. Luckily, one of them was, or actually both of them were on the had y-intercepts. So that gives me y equals positive 4/3 x minus 2, and y equals negative 4/3 x plus 6 for my asymptotes. Next, I need to find the foci. C squared is going to equal a squared plus b squared. So that's going to be 25. So C is going to be 5. So my foci are going to be 5 to the right of my center. So that's going to be at 8, 2, and 5 to the left of my center, which is negative 2, 2. Okay? Again, you need to practice this stuff this week. This is going to be on Friday, or excuse me, on Wednesday, and you are going to have to go with it.